and I'll just hand over to the next speaker, which is Professor Verity Brown, who shall talk about Of Mice, Rats and Men, how research contributes to business and industry.
Okay, thank you very much for inviting me. It's a great pleasure to talk to you today. Okay, so what does psychology research contribute to industrial and the economic output of our country is the brief that I'm going to talk about today. So this declaration, I spent quite a lot of time working with industry actually. I had a Royal Society Industry Fellowship for 5 years between 2007 and 2012. And I've also in the past 5 years received grants, including support for my research, studentships, travel to conferences, speaking, consulting from a variety of companies all involved in the pharmaceutical sector. Okay, basic research. This is the Frascati definition, which is the Organisation for Economic Cooperation and Development, the OECD, defines basic research as follows. Experimental or theoretical work undertaken primarily to acquire new knowledge of phenomena and observable facts without any particular application or use in view. It's usually undertaken by scientists who may set their own agenda and to a large extent organise their own work. That's us guys. Okay, but this is the important point, without any particular application or use in view. So at the time that you're doing the research, you don't necessarily know what you're going to be doing with it. But that doesn't necessarily mean it's useless or something won't happen to it. And as Keith showed in his talk, we discover things serendipitously by chance that often result in spin-offs and make money. But I really want to talk then about research which is designed to do something. Okay. Some of us have an image problem, and that is that we're largely nerdy and irrelevant. It says sociologists on strike, but I'm sure you can understand it works for psychologists as well. Nobody would particularly notice if the psychology department went on strike. At least you wouldn't notice immediately. Okay, industry has a problem too, and in particular the pharmaceutical industry. Words like big pharma is never meant as a compliment, and so psychiatry, in particular, is seen as a way that big pharma makes lots of money and doesn't actually do a whole lot of good. So they also have an image problem, greedy and selfish. My thesis is that by working together, actually, neither of these things are true and accurate, and that by working together, maybe both of those can be overcome. Scientists have a knee-jerk aversion to any claim that science is shaped by culture. The idea there's a one-way street from pure, read noble, to applied, read grubby science is nonsense. And who but society decides what it wants to make, or which efforts are interesting and worth supporting in the first place. Okay, so pretending actually that yes, we are inquisitive creatures, but the things we choose to inquire about is actually shaped by the important things that are in our society. Things that other people, including politicians and government, but actually just other people, our culture, find important. And that's therefore, that does largely determine and shape where our research efforts are directed. And some of you have seen this slide before. This is one of my favourite quotations. Research that is highly cited or published in top journals may be good for the academic discipline, but not for society. Research that gets widespread press coverage may be the result of academic streaking, not quality. Research that is loved by user communities may be so because it's glib, sycophantic and unchallenging. Such research may be the antithesis of high-quality, independent research based on a deep understanding of problems and their potential solutions. I think that last sentence really sums up the position I take on this topic. It's not a distinction between pure science, noble, or grubby science, applied. It's actually finding the deep understanding of the problem, knowing what it is you want to solve, having some idea or some clue about where the solution might be, and then conducting high-quality, independent research. So not necessarily paid for by a drug company, and that's one of the reasons why one always stands up and makes a declaration. I've been funded by a company, so that nobody can turn around and say, oh, you would say that, wouldn't you, because your money comes from them. Right. So that's what we really all want to do, high-quality, independent research, a deep understanding of problems and their solution. So what's to be gained then from working with industry? The chance to do this high-quality, independent research. Both parties in this relationship must contribute something, whether it's the skills, expertise, information, equipment, technology, communication channels, or finance. Many academics actually think that companies provide money and we provide the skills, expertise, information. In fact, actually, that's not necessarily true. So particularly in many industries, have their own research and development departments, and those R&D departments are chock full of skills, expertise, information, equipment, technology, communication channels, as well as finance. The finance is nice. So often when we find ourselves working with industry, it's not that we're the ones bringing skills to them, or knowledge or the experiment, but there's an awful lot to be learned as well from what's going on inside the companies. There are many different types of relationships. So, for example, at one extreme is just a fee for a service, which is often consulting or sponsorship of some kind, leading all the way through to project funding. And then finally, the one that I think is probably the most rewarding for both parties is when you're doing joint working, which is also risk sharing. So that's when you become essentially part of the R&D operation of the business. You don't have to go into the business necessarily, but when the information flows in both directions, and so you benefit from what they know and they benefit from what you know. So there are different levels of engagement activities, and I think actually Andy's talk later is going to be talking about one level of engagement with other people outside of academia, which is sort of awareness, and that in industry terms that's often career talks. So they come and people from industry come and talk to you and explain to you could work for us in our R&D or whatever, all the way through to involvement, which tends to be things like internships, which many of you will spend this summer doing, I'm sure, as well. Support, which could be funding or seminars or information basically coming from the company, up to sponsorship or strategic partnerships, which is really when you start doing things together, R&D solutions, for example. Okay, so you know about technology push versus demand pull. So this is the distinction between got something, wonder what we can do with it, that's where the iPad comes from, versus my vacuum cleaner doesn't work very well, how can I design a new one? So that's called demand pull. Okay, so we have the same thing in academic research. So I would argue that this, for example, is one example of a case of demand pull. So this is a depressed patient. This is what we need to find. We need to find drug treatments for depression. What academic research can contribute then is things like, for example, Lesak referred to the separation of depression from dementia is the knottiest problem of differential diagnosis. Well, if you can't diagnose your condition, then you're not going to be able to treat it. Okay? And anyway, you wouldn't know whether you've been successful in treating it because you wouldn't know whether you got it. So, at the very beginning, what psychologists can contribute is a better diagnosis of these disorders. That's not the business of a pharmaceutical company, but obviously they very much care about it because they can't progress with drug development unless they get this differential diagnosis sorted out. So that's an example where we can offer something because there's a need out there. We detect the need and then we can start doing things about it and do the kind of research that will address that need. This is a diagram from Helen Mayberg. It's a very simple circuit diagram of these are different brain areas, and essentially this is an explanation of depression. Okay? It's a model, and she's suggesting here that medications, pharmaceutical solutions, operate in these pathways. Doesn't really matter what these brain areas are actually. Cognitive behavioural therapy operates in this pathway, while deep brain stimulation operates in these pathways. So what this tells us, for example, is that long-held belief that I'm sure you heard back in the day, drugs versus psychotherapy, talking cures versus pharma. Right? It doesn't matter, it's irrelevant. The question is solved. It's all this. It's a big complicated circuit that could be modulated by CBT, it could be modulated by medication, and it could be modulated by deep brain stimulation, all modulating the same circuit, all contributing. So this is again something that academic research contributes to industries, this is the background information for the demand pull. So this is an example from psychophysics, and this is an example of what I would call technology push. Since the very first psychological laboratories, studying perception was one of the first things that was done, actually, even before we had very good knowledge, because this is how stuff gets into the brain. So whether it's studying taste sensations or binocular vision, looking at eye movements, perception has been something that is not immediately obvious how it could be applied in industry at first, until one starts to consider where we're going now. So this is the Galaxy smartphone about to be released, and the idea is that just looking at it, you'll be able to scroll the phone with your eyes. It's remarkable. Would never have got there had we not had some way of measuring eye movements. Okay, so the perception research came first and provided the opportunity then for the technology that's now being developed. Similarly, three-dimensional television. So when I was sitting in your place as an undergraduate, yawning through those binocular disparity lectures, thinking, oh, why do I need to know this? Well, of course, now it's incredibly important, and some of the secrets of depth vision are held, they're patents that are held inside companies. So to the extent to which an academic needs to know some of these things, you have to get inside the company to find out, because they're moving ahead on some of this research even faster than we can. pouring heaps of money into it because obviously the potential is so enormous. This is another example actually of neither technology push nor demand pull, but opportunities for collaborative working. So this is a map showing Unilever's research and development stations. Doesn't really matter where they are, just put it up. And these, I'm sure you'll recognise some of those brands. What will strike you by that pretty coloured picture is all the packaging is in different shapes, sizes, colours. Right. A psychologist did all of that. All of that was done by basically, what sells, what kind of, this is your fabric softener comfort, right? The shape of the bottle and the font that's been used has been worked out very carefully by lots and lots of market research, marketing research by psychologists. Okay. So how do you get involved how do you do this? Because obviously we sit inside a university and they don't often come to us. Sometimes they do. There are exactly. Eric and I were approached by a company that wanted to do a project about rat behaviour and rat motivation and food approach. It turned out they were actually a pest control company. So sometimes they come directly, but there are also lots of organisations. So this is the Scottish Universities Life Science Association, and they do these Spark Awards, which is basically to try and encourage collaboration. So they do things like speed dating between industry and academics to sort of find out, what have you got, what can we do together. There are these things that companies use these as well, sort of interface things where scientists can put up their CV and their skills and expertise, and companies can then check and find connections and find partnerships that way. There's the Royal Society Industry Fellowship I had. This is a good one too, Crack It Challenges. It's a competition to connect and fund scientists from different disciplines and sectors. So you put up your problem on a website and an academic can browse all these problems and think, oh yeah, I could do that, actually I know how to do that. Okay, so that's the end of my presentation.